Here we are at our example 2A from our 2.6 set of notes. Now we're told that we have a table which lists the wind chill factors, and the wind chill is pretty much an indication of how cold it actually feels outside. So typically when you're watching the weather, they give the actual temperature, but then also the wind chill, just so you know what it feels like as it's outside, because again, that wind component, for various temperatures in Fahrenheit. Now, there's a 15-mile-an-hour wind that's blowing here, and we're asked, what is the correlation of this data? Now, before we actually begin in answering what A is, we're going to go ahead and first graph and plot these different points right here. So we'll let our actual air temperature be our x-axis, and our wind chill, in other words, what it really feels like with this wind kind of going, be our y value. So again, our actual air temperature is our independent variable, which might have an impact, a direct impact then, on how it actually feels with that wind being our dependent variable. So again, here is our x-axis, the actual temperatures, and here is our y-axis with that wind chill taking into account. For the x-axis, I'm going to go ahead and go up by 2's. It should scale nicely if we go up by 2's. And for our y value, we're going to scale that by 3's. So we're going to go down 3 for each little tick mark. So by 3's. Now for our first data point, we have it at -5 and -38. So -5 would be, here's -2, -4, -5 is over here. And then we're going to have to go down. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39 would be about here. So our data point right here then is right around there at that -38. So let's just mark, -39, 36, 33. So this would be -30 right there. At 0, -31, we would see a data point right about here. At 25, at that air temperature, we would end up with a wind chill factor of 2 degrees. So at 25 degrees. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So here is 20. We have 22, 24, 25. It's going to be a data point about right here. So there's 25, and then 2 degrees. 10, -18. So here's 10, -18. It would be 3, 6, 9, 12, 15, 18, right there. 20, -5 would be about right here. 15, -11 would be, here's 15, and then -11, we have -3, 6, 9, 12, so we're looking at a point of about right there. And then lastly, 5, -25. So looking for a data point about right here. So this is roughly what our data looks like when it's plotted. Now we're asked to determine the correlation of that data. And just looking at it, we can notice that if we were to draw a quick kind of line through this data, more or less, there would be our line. Notice how it's really compact and together, all that data. So we do have a positive correlation because it's going up. And our R value, which represents how well that data fits our line, is really compact. We can see that the data points almost identically line up. By and large, they are lining up with our red line. And as a result, we know that our correlation coefficient is that R value between -1 and +1. And since it's positive, we have a positive correlation here, it's going to be really close to this R value being 1 because of how well this data fits the line. I mean, it's pretty much all on this line. And that's why R is really close to 1. So we could say that R is about maybe 0.9, we'll say 5. Just this is an estimation for right now. There's a way that we can do it in the calculator, and we'll kind of do that for our tier 3 if you want to explore that. But just know that for right now, it's really, really close to 1. If you have a correlation or an R value close to 0, that's pretty much where our scatter plot is all over the place and we can't make much of a correlation. If it's closer to -1, that's where we see the negative correlation, and it's really compact like this too, only it's going downwards. But we're going to see another one of those where we can see it a little bit better too. So again, though, that is example 2A from our 2.6 set of notes.